Hello and welcome. In this video, I'm going to show you how to model mass transfer with convection in COMSOL Multiphysics. We'll simulate a reacting flow with reaction source. At the inlet, the velocity is 0.1 meter per second and mass fraction of component 2 is 0.1. Our goal is to determine the velocity and mass fraction distribution throughout the domain. Let's get started. For the study model, select Model Wizard. In this section, we need to define our dimension because we have 2D simulation, so we select 2D. In this section, we need to define our physics, so select chemical species transfer. And here, open reacting flow and select laminar flow and concentrated species. Okay, and now select study. In this model, we have a steady state simulation, so we select stationary. Okay, right click on geometry, select rectangle, and the height is 1 and the width is 5. Okay, and now let's mount laminar flow and right click. In this section, we need to define our boundary condition of the fluid flows, so we select inlet. The inlet velocity is 0.1. And now we define our outlet boundary condition, so right click laminar flow again and select outlet boundary. Okay, for the outlet boundary condition, we have pressure and its value is 0 because we have a relative pressure in the outlet. Okay, and now select fluid properties, and for mu we use 1 e minus 3 Pascal product seconds. So it's our viscosity. Okay, and now select transfer, right click. Here we need to define our boundary condition for mass transfer. So here we select mass fraction for the inlet. Okay, so we select species 2 and here we have 0.1. Okay, and now right click again and we select outflow. Okay, now click on species molar masses, and here for MW1 we have 18 and for MW2 we have 46. Okay, and now click transfer properties 1. Okay, when you click on transfer properties 1, you have some properties here. So for the mixture density we use user define, and we use 900 kilogram per cubic meters. Okay, and now here you see, now we define reaction source. Okay, so reaction sources, and we select our domain, and here we use minus 0.5 for the reaction source. And now click on mesh 1 and click on build R. Okay, now select stationary and compute the model. Okay, the calculation has been completed, and here you see the velocity distribution entire domain. So in this section, you see that the velocity in the wall is 0 because we have no slip boundary condition. Okay, and now select pressure is about the pressure domain, and the important result is a mass fraction of the component 1 and also component 2. So here click on surface 1, and here we use W1 for investigation the mass fraction of the component 1. So click on plot. Here, as you can see, the mass fraction of the component 1 increases as the length of the domain increases because we have a reaction source for the component 2. So now click concentration 2, and here surface 1 we use, for example, W2 if you want to check the mass fraction of the component 2. So now click on plot. Here you see the mass fraction of component 2 decreases because we have a reaction source for this component. Okay, thank you for watching the video.